There we go. Great. Let's start by talking about what it is that you and your team and your company want to accomplish on AWS. I'm going to guess that you came to the cloud because you want to quickly differentiate yourself by building something that has value for your customers. And the key word there is quickly. Right? We want to be safe, we want to be secure, we want to be compliant, but we can't move so slowly that it takes us too long to deliver something to the market in time for it to actually matter to our customers. So we want to move fast. We want to stay secure. At the same time, we want to also lower costs. You basically want it all. And I'm hoping that today we can show you how to accomplish all of that by automating your delivery pipelines with infrastructure as code. My name is Eric Beard. I'm a solutions architect at AWS. I'm joined today by Kevin DeYoung, who's also with AWS, and by Damian Silbergleith, who's with GoDaddy. He's got a really great story to tell about how his team built out a platform for using the tools that we're going to talk about today to allow their developers to move quickly and safely as they build out applications on AWS. First, I want to talk about the concept of safety at speed. At Amazon, we have hundreds of autonomous development teams who are constantly deploying to production. This adds up to something like 150 million deployments a year across Amazon. This number actually is a little out of date. I think it's much higher than that now. And we're able to do that with a very high level of safety and security. Security is absolutely the top priority for development teams at Amazon. We support roughly 100, I think over 100 different compliance certifications for regulatory agencies all around the world. That helps us satisfy our compliance requirements and our customers. And we have third-party auditors come in several times a year to audit our processes and our procedures. So we have a very high confidence in the way that we do things, and what we're going to talk about today, these are the tools that we use here at Amazon. What is infrastructure as code? Before the cloud, when we were operating in data centers, for building out our infrastructure, it was a lot harder. We had to order the hardware, get it delivered to the data center, drive to the data center, install the operating system, get the networking set up. There were all these things that required you to be physically present to set up your infrastructure. And I realize there's going to be quite a few people in the crowd that were kind of born in the cloud, but I'm sure there are plenty of you out there in the audience who have been there. It's 2 a.m., you're at the data center, you're looking for that last screw you need to get that server attached to the rack so you can finish what you're trying to do. And then the cloud came around, and suddenly we can do all of that with just a few button clicks. It was great. You go in the console, a couple clicks, I've got an EC2 instance. I click the button again, I have another EC2 instance. This is amazing. It was revolutionary. But then, you operate that way for a few years, and you realize the way you're operating is kind of fragile. You have these super complicated runbooks that you have to follow. You have things that maybe aren't very well documented. You've got stuff that's just all in one person's head, and if they leave, it's going to be really hard to figure out how you got your environment set up. Maybe you have a bug in production that you're trying to troubleshoot, and a developer can't accurately replicate what that production environment looks like, and they're struggling to fix it. Or you're trying to set up a disaster recovery environment. You need, just in case you have an issue with your main environment, you want to be able to flip over quickly to a backup environment, but that's really hard to do if you can't remember all the steps you took in the console to actually set those things up. Infrastructure as code to the rescue. Now, we can specify our entire infrastructure in text files. We can check those into source control, and now we can apply a whole host of developer tooling to our infrastructure to make sure that we're following best practices and that we're being secure. One of the biggest benefits you're going to get from infrastructure as code is consistent deployments. We want to make sure that we are setting up the same infrastructure in exactly the same way in all of our environments. And we're going to start with a developer sandbox account. And so speaking of sandboxes, I'll get up on my soapbox for a minute and sort of preach about how we really highly recommend setting up multi-account architectures on AWS. And we highly recommend giving all of your developers, all of your engineers, their own AWS sandbox account, at least one, to do their learning, experimentation, testing, and development. And you know, I do get some pushback from customers on this sometimes. You know, they'll say, look, you know, giving everybody their own accounts and adopting a multi-account architecture, it's costly. You know, it's complicated. You know, but I spend a lot of time as a specialist, you know, a specialist for DevOps and IAC, working with customers who are dealing with really hard problems that come from putting too many developers in one account or too many applications in a single account. And I can tell you that those problems end up being more costly and more complex to solve than it is to get, you know, like a secure landing zone set up with control tower where you can set up guardrails for everyone. And, you know, I talk about productivity, you know, and the other big benefit of that is, you know, I would imagine that everybody in the room here for this talk today is very security-minded. When you think about security, if you can get things down to where you're putting less things in one account and less people in one account, security becomes easier, right? It's easier to craft a control policy or permissions boundaries to limit what that one application or that one person is doing in that account. So I think doing that makes you a little bit more secure as well. So I'll get off my soapbox now about that. I might get back up on it a little bit later. But so now we've done that, and the developer is happy with what they've built in their sandbox, and now we're going to roll out an automated delivery pipeline for these infrastructure changes. You know, we're going to roll it out to a beta account. We're going to roll it out to a gamma account, and then we're finally going to go to prod after we've tested things. This is all automated, and that automation is enabled by infrastructure as code, because everything is in these text files. Everything is going through, you know, the coding procedures, code reviews, integration testing, and it's all automated. The next big benefit you're going to get from infrastructure as code is that now you can apply developer tooling to your infrastructure. Now we can use static scanners during the build phase. We can take a look at these template files, and we can make sure that we're following best practices. So what we're trying to do is shift left. That's a big term in the industry right now. Like, we're shifting these checks left to the developer so the developer can validate them and make sure that their code is OK. And of course, we're going to apply the trust but verify philosophy, and we're going to recheck all of these things later in the pipeline and make sure that we're not actually deploying anything that's not compliant or not secure into our environments. AWS CloudFormation is our infrastructure as code service that we offer at AWS. So CloudFormation is a server-side orchestration engine that takes the template files you create, and then it handles all the really complicated details for you of how to create and update and delete all of those resources in an atomic way, right? We're going to apply all of those changes, and if something goes wrong, we're going to roll everything back so it's in exactly the same state that it started with. So I'm curious, out of the folks in the crowd here, who has never used CloudFormation before? Like, you've never written a CloudFormation template? Like, how many people are just like brand new to CloudFormation? So just a couple of folks. So for the folks that are new, the way that CloudFormation works, the way it's organized, is it organized resources into something called a stack. So generally, you write one template file, and that turns into one stack. And a stack will have a set of related resources in it. Like, you know, a stack might be some EC2 instances of VPC, security groups in one stack, or maybe you have a different stack that has a DynamoDB table, a Lambda function, API gateway for a serverless application. You know, it's good practice to break things down and not put too many things into a single stack. And like I said, CloudFormation, it's not a client-side tool, it's a server-side tool. So it's going to handle all those complex details for you, you know, making sure your dependencies are getting rolled out in the right order, doing rollbacks. And what this gives you, the fact that it's server-side, is this gives you a lot of long-term operational stability. Cloud Development Kit, AWS CDK. So the Cloud Development Kit is a development framework. It's an open source development framework that allows you to specify your infrastructure using your favorite high-level programming language, as long as your favorite is one of the ones we support. Java, JavaScript, TypeScript, Python, C#, and Go. I think I got them all there. So, you know, as you can see on the screen here, we're creating a network load balanced Fargate service, which is a fairly complex setup in about a dozen lines of code. This is going to result in, you know, maybe 50 resources being created in your account. And CDK is built on top of CloudFormation. So when you synthesize this CDK application, you're creating what's called a cloud assembly, which is a collection of templates and assets. So CDK handles the deployment not only of the infrastructure in the template, but also the related assets like Lambda functions or Docker containers for you. I think that the CDK is probably one of the better examples of a successful open source project at Amazon. We have hundreds of unique contributors every year that are working on the CDK in combination with a core team at AWS that maintains the CDK. And CDK is something we use heavily. We dog food this at Amazon. It's not just something we created for customers. We use this internally. So I want to talk just for a minute about kind of the design philosophy around CDK, why we designed it the way that we did, because it has a lot to do with deployment safety and security. What we found was, when we looked at reasons that our deployments fail, reasons that we might have outages sometimes, we looked into it, and it's not often actually that it's like the runtime code that's failing, right? Developers are using fairly disciplined processes. They're doing code reviews and unit tests, and like by the time that code gets to production, it's usually pretty good. When we have an outage, what we found is a lot of times it's an out-of-band change to your application that happened. The developers shipped their binary or their deployment artifact, but somebody had to like log into the production account and change a network setting, or there's an environment file that had to be edited and there's a typo in that file. Like there's little things like that that happen that would cause these problems. So the way we you kind of used to do things, things were siloed. So we talked about having that infrastructure team that was driving to the data center to install the equipment. We have our development team that's writing the code, and then maybe they're throwing it over the fence to a QA team, and then maybe they're throwing it over the fence to an operations team. And even if your team has started to adopt modern development practices, and it's kind of one autonomous team doing everything, you still see these divisions in the code, right? Like you can go and you can see there's the infrastructure project over here, and then you have the runtime code over here, and then maybe there's some separate configuration that you're using for how you're going to deploy your software. So what we wanted to do with CDK was to make all of those things one thing. So after we've bootstrapped a set of accounts, we're using a landing zone, maybe an account vending machine. We're setting up accounts, and we've got maybe a central team is making sure that we've got our security guardrails installed in those accounts. After that point, when the development team takes ownership of those accounts, nothing in any of those accounts ever changes that doesn't go through this one CDK application. So it's one Git repository, one app, and we put everything in here. So we have the infrastructure. So VPCs, buckets, functions, everything is in here. Also, all the runtime code is here. The entire delivery pipeline is also configured here. So if we're using, say, code pipeline, code build, the configuration for all that is in this app, and the configuration for those different stages. So we're sort of flipping things on their head with CDK. Whereas in the past, a development team's job was to create this immutable deployment artifact. Then an operations team is going to take that, drop it into different environments, and configure it. In CDK, all of the configuration goes into the app itself. So you'll have your beta configuration, your gamma configuration, your prod configuration. So even if all you're doing is changing the configuration of a firewall or a security group or a bucket, that's going to go through a change here, and that's going to get rolled out through your delivery pipeline. So in order to make this a little bit easier, setting up these delivery pipelines, we created something called CDK pipelines, and this is a CDK construct that takes away a lot of the heavy lifting from setting up cross-region and cross-account delivery pipelines. Any of you have had to do that manually, clicking around in the console, or maybe you've written it out manually in CloudFormation, knows that that's a lot of work. There's a lot of security considerations to take into account. So CDK pipelines just makes that a lot easier. And so what we have on the screen here is sort of what I would consider kind of a canonical setup for a new team who's making a new app, a new microservice. We're going to set up a dedicated CI/CD account, a set of accounts to deploy into. And so then, I'm doing my development, in my sandbox account, like I mentioned earlier. So I'm doing my development. I get to the point where I'm happy with it. I send it over to Kevin for a code review. Maybe he kicks it back to me for a few times for changes. We go back and forth. And then once that code review is done, it gets checked into source control, and that's when the automated delivery pipeline, starts rolling out. And so the important thing here is that, you often look at this and you think, oh, that's how our coders make changes to the web app or make changes to the REST API or whatever. No, we're going to use all of these same processes for infrastructure changes too. So we're going to treat infrastructure as code and use all of these delivery pipelines for that as well. So I'm going to talk about DevOps for a minute, and I know you're here. You're thinking, wait a minute, I thought this was an infrastructure as code talk. This is the security talk. Why are you going to talk about DevOps? And the reason really is that automation is at the heart of DevOps, and it's really hard to be secure and compliant with your infrastructure if you're not automating everything. I realize DevOps is a totally loaded term. I ask everybody in here what their definition is, and I'm probably going to get that many different definitions of it. But the way we think about it at Amazon is it's a culture, and we have kind of 3 high-level tenets that we like to talk about. First is to break things down. Like you really have to break your applications down into smaller pieces that are easier to manage, easier to reason about, easier to secure. And then we try to treat our teams, our development teams, as autonomous businesses. Amazon is really more like, a couple of thousand startups all working together on a bigger problem, right? So we try to let those teams move quickly and own their resources, own their accounts, own their own operations and security. And the way that those small teams are able to accomplish so much by themselves is automation. We really take automation to the next level, and we try and automate everything. And that's really where infrastructure as code comes in, because you can't automate everything if you don't have infrastructure as code. So I'll talk briefly about kind of the different phases of this software development lifecycle and delivery lifecycle, and Kevin's going to go into much more detail about the different tools you can plug into each of these in a bit. But so we have that development phase, and this is where we want to be as fast as possible. We want to make those developers productive. We want to give people their own sandbox accounts, let them iterate, let them experiment. Then they get to the point where they do that code review. We get through that, and then we check things in to source control, and we use trunk-based development here at Amazon. We don't use Git flow, we don't use branch-based development. As soon as something gets merged into mainline, if all of our tests pass, that's rolling out to production. So once something gets checked in, then our automated pipelines. Did I lose my? Oh, I have it. I thought my audio cut out there for a second. Sorry. So we have our build processes, and this is where we're going to plug in all of our static scanners, and we're going to make sure that we're following best practices here. And then we're going to package up the build, and then we're going to move on to actually deploying. And like I mentioned earlier, in that kind of canonical setup, we have beta, gamma, and production. And so this is the beginning of that automated pipeline. So we're going to start in this beta account. And this one is sort of like an anything goes account. This is where this is the first place your code's all getting together, and you're doing all your full integration tests or end-to-end tests, making sure everything's going to work. You kind of expect some things are going to fail here. And this is an account where all the developers on this team should have administrative access to this account, and they should be able to use the console. Don't limit people to the CLI, don't limit their access. There's no production data in this account. So developers should have the freedom to get in here and figure things out and troubleshoot, and then go back and make a code change and roll that out. And I'll emphasize the fact that there's no production data here outside of the production account. That's one temptation you really have to resist, as I do see folks saying, oh, well, in order to test things properly, we need to grab some production data. Don't ever do that, right? There are ways to synthesize realistic data that you can use to test on. So you really want production to be production, and that's the only place where that data lives. So let's say we've gone through beta. Now those tests have succeeded. We're moving on to gamma. And in this gamma account, this is locked down. This is completely locked down. We treat it just like production. Developers are not logging into this account. And we're going to run all of the same tests that we ran for beta, but maybe a few more. We might run some more realistic synthetic tests on the user interface. We might run load testing here. We might want to put a realistic production load on this system and make sure that some setting that we change, like maybe the only change we're running out is a network setting. But maybe we want to do a load test here and make sure that that network setting hasn't made it so that we can't stand up to a production traffic load. And then if all those tests pass, then we roll out to production. And this might be a phased rollout, one fleet first or one region first, make sure that's good to go. We're being super pessimistic in these phases. We're looking for any reason to fail, do an automated rollback, start over, and then somebody has to go make a code change and roll that back through the pipeline. And so now I'm going to turn it over to Kevin. He's going to go back through each of these phases and talk about the specific tools that you can use and plug into those phases in the delivery pipeline. So,
perfect. Thank you. So hello, I'm Kevin DeYoung. I'm a developer advocate for infrastructure as code at AWS. For those that work with CloudFormation, I'm also the creator and maintainer of cfn-lint, a tool for validating your CloudFormation templates, thank you, prior to deployment, hopefully making life easier for you along the way. So, and as Eric mentioned, I'm going to be diving into the software release cycles to discuss some of the solutions, products, and services that you can use to do security and governance on your infrastructure as code. So we're going to start with the develop phase. During the develop phase, right, typically your developer is working inside of an IDE, working on their CDK app or their CloudFormation YAML or JSON templates. As Eric mentioned too, our goal is to shift that feedback left. So we want to give that developer that information inside the IDE or inside the CLI as quick as we can give it to them so they understand their issues and their misconfigurations and can resolve those before they even do a commit or submit a PR. So by providing this feedback, we're hoping that the developer can work quickly, release those business features and capabilities faster. So in the following slides, we're just going to go through some of the tools that we would recommend. So I'm going to start with the purpose-built solution for CDK. So CDK is an open source solution that allows a developer to validate CDK apps during the synthesization phase. And just so you understand, Eric kind of mentioned it as well, right? CDK generates CloudFormation templates. It does this during the synthesization phase. So by having cdk-nag do this work at this point, we're not actually even creating that CloudFormation template we can deploy. It will fail, and we don't even get that template to actually go and create a stack. So, and then additionally, cdk-nag comes bundled with nag packs. And you might ask then, what is a nag pack, right? So nag packs are a collection of rules that are used to validate your CDK app against. As you can see from the slide, right, there are plenty of rules out there to get you started and get up and running quickly. But as an organization, you can also customize your nag packs, right? You can create your own security standards and put your own rules into those nag packs and put them into your CDK app. So in this code sample, you will see that with a few lines of code, we're able to add the AWS Solutions Check nag pack into our CDK app. It's just an import and a few lines there. And then we're going to run through a little example here. So this sample, it's a simple CDK app, just creating an S3 bucket. We're naming the bucket, configuring public or block public access on the bucket. So pretty simple, right? So then when we run our CDK synth, cdk-nag is evaluated and will display the issues to the developer. So in this case, right, we get alerts for not adding S3 bucket logs, and then doing the require SSL traffic to the bucket through a bucket policy alerts from the cdk-nag. So again, right, I didn't even get that template created from here. I'm getting that failure. I can resolve that, work on that locally, and then do my commit and PR. So the next solution we'll discuss is CloudFormation Guard, which is also an open source solution that leverages the Guard DSL to create rules that can validate any JSON or YAML document. So the cool part about this is CloudFormation Guard can work against CloudFormation, YAML, or JSON files. It can work against CDK synthesized apps once we get the YAML out from CDK. But it also works for Terraform plan documents, Kubernetes documents, Helm charts. Anything that's JSON and YAML, we can do with Guard. So with CloudFormation Guard, that rule writer has the ability to allow the developer to suppress the rule. So you get some flexibility in how, if you want rules to be suppressible or if you want them to be required. But that's all on the rule writer to decide how they want that to be put together. So it is worth noting, right, that CloudFormation Guard by default does not come with any rules out of the box. But we will talk about some other options available and some rules that are available for you. So this is a CloudFormation Guard rule that is validating all S3 buckets in a CloudFormation template. You can see in line 1 there, right, we have that asterisk, and we're looking for the type of AWS S3 bucket. And then we're looking at those buckets, and we're trying to evaluate if they have server-side encryption enabled, and we were requiring AWS KMS for that server-side encryption. And so we have that rule kind of written there. You'll notice, I'll call out a few things like line 7, right? If there are no S3 buckets, we don't want to evaluate the rule. It doesn't make sense for this template, so we can skip it. Also, additionally, lines 2 and 3, when we talk about the rule writer having this ability to let the end developer suppress the rule, that's what you're seeing on line 2 or 3. So if I didn't want them to suppress it, I could just remove those lines, and they can't suppress this rule. So again, examples. So we're going to take an example template, and we're going to run Guard against it. So this template represents the bucket created in the CDK app from the previous example, minus a few little tweaks. But it's pretty much what we got from the CDK app in the last one. Here again, we're enabling versioning, but blocking public access, naming the bucket. So now when we run cfn-guard validate against it with that rule that we had and the template that I just showed you, we will get back this failure, right? You can see from the property path, the path to the issue that we had. We're missing a property in this case, so we're actually seeing what property was missing. And if we did specify it, it obviously would validate that it was AWS KMS, not SSE, I think is the other one. So, as I mentioned, CloudFormation Guard does not come with any, is that my audio? Okay, sorry. CloudFormation Guard does not come with any rules out of the box. However, there is an open source Guard registry that includes a bunch of rules for you. It has rules for over 40 different frameworks, so a great spot to get started. And you can just download those and just implement them into your Guard implementation. The last tool we're going to discuss is cfn-lint. Mine, I guess. So cfn-lint, a tool for validating your CloudFormation templates. We use the resource spec to do this validation, which is just a big JSON document that describes the shape of resources and their properties, and we do a bunch of things on top of it to make it better. So we leverage pricing data, SSM data, to build a bunch of rules to help your validation go better. But organizations have the ability to customize and add their own rules into cfn-lint as well. So if you need a more robust language to maybe write a rule, maybe you have to make calls to outside APIs or different things like that, you can do that in Python, which is what cfn-lint is written in. So we're going to kind of compare the tools that we just talked about a little bit, just to kind of call out a few things again to make sure we're all clear on them. So cdk-nag, right, only works with CDK. CloudFormation Guard will work across any YAML or JSON, and with CDK, once you synthesize that template out, and of course, CloudFormation. cfn-lint works with the CloudFormation YAML JSON, CDK, once you synthesize it out, but doesn't work with any YAML or JSON file. It only works with CloudFormation YAML or JSON files. Additionally, right, Guard does not have included rules, but as I've shown, there's a rule repository out there. You just need to go get them and bring them with. The next solution I want to talk about is CodeWhisperer. So CodeWhisperer, right, is a generative AI IDE plugin that will help you generate your code to accelerate development and frees up those developers to work on more business-critical problems. But by providing a descriptive comment, CodeWhisperer will generate infrastructure as code for us. This will work across CDK, YAML, JSON, and Terraform. So you have a lot of options in here and using CodeWhisperer to help do this. The other thing to note, right, is CodeWhisperer is we help train it to provide the best solutions when working with AWS as well, and that will work again against all those CDK, YAML, JSON, CloudFormation, Terraform. We'll try to provide those best examples when working with AWS. The other feature of CodeWhisperer that's worth discussing is the security scanning. So help developers stay secure, right? CodeWhisperer also features a security scanner, and you can do this directly inside your IDE. In this example, right, we're just looking for hard-coded access key, and it's going to alert us to this issue, so now I can correct this and do this back. And it is also worth noting, while this slide doesn't show it for the infrastructure as code stuff, this is available for CloudFormation YAML or JSON and Terraform, I believe, as of Monday. So this will also do some scanning of your infrastructure as code templates. So in the build phase, we are using services like AWS CodeBuild to take our code from source control and to run tests that should have been caught ideally locally. Again, back to Eric's point, trust but verify, right? We're now verifying that the developer ran those tests locally, or maybe we're running more tests that don't fit that developer workflow easily. Maybe they take a lot of resources or time or things like that. So with AWS CodeBuild, right, every check that was run during the development will be running before committing, right? We can run again to make sure nothing was merged into that trunk that doesn't meet our standards. Every CodeBuild project has a build spec, which is a YAML file that you write your build instructions into. And then additionally, in many scenarios, right, CodeBuild is also used for doing the deployment. Again, it's just another command in that YAML file that we can use. So in this example, we're just going to run Bandit against our Lambda function or a CDK Python app. And so when we fail command, the AWS CodeBuild job will fail. And we can look into logs to see what that failure was. And inside here, right, we can see that Bandit failed. We see what the failure is, and we can make that correction inside of our code. So the next thing we're doing during the build process is image scanning. Amazon ECR image scanning helps in identifying software vulnerabilities in our container images. So with basic scanning, ECR uses the CVE database from the open source Claire project to scan on push. And then with enhanced scanning, ECR integrates with Amazon Inspector and CloudWatch events to do continuous scanning of our repositories. Inspector is a more holistic service that goes beyond just what ECR does to look for vulnerabilities in our running workloads. So, deploy phase. So during the deploy phase, we're creating and updating and deleting resources in our AWS account, right? So this is our moment. Ideally, all of our IDE integrations, all of our build phases, right, should have caught all the possible issues, that would be deployed, right? So, but what if our organization has more complicated rules than that, or some other thing is going on there? So think of things like maybe we have rules that are dependent on additional information. It can't launch instances into a public subnet, or RDS instances have to go in these set of subnets. Typically, users get that information from other stacks, because we usually layer those stacks, right? So whether it's a CloudFormation import-export, an SSM parameter value, a dynamic reference, a lot of different things could be included in there, and how to get those values into our stack. So, and additionally, there's scenarios where the developer maybe has a lot of freedom in building that pipeline. And maybe we just want to trust but verify again that they're actually running these checks and didn't just disable them all inside their pipeline. Additionally, with CloudFormation, as many of you may know, there's a lot of intrinsic functions and different things you can do to make your templates very reusable. Find-in mappings, conditions, refs and get-ats. All those things make the validation of that information harder on the IDE side because we don't get those resolved values. So that can kind of slow down what we can do, and we just want to make sure, again, before we do that deployment, that that resource is valid. So to solve this issue, we can use CloudFormation hooks. CloudFormation hooks are a server-side solution that validate a resource prior to updating, creating, or deleting that resource. You can select resource types based on the wildcard or the specific name. So you can see on the resource types there, you can kind of get pretty free on what you want to select. So since this is happening on the CloudFormation service side, the developer can't skip them. The other benefit is that all the CloudFormation intrinsic functions are fully resolved. So get-ats to other resources, refs to parameters or SSM parameters, mappings, conditions, CloudFormation imports, right? They're all resolved, and we're getting the final values to the hook. This means we can really validate and make sure everything is the way we want it to be. So additionally, the hook implementer will have the ability to have a rule fail or warn on the deployment. So when configured to warn, the error will show up in your CloudWatch stack events, but the stack will continue to deploy and the resources will continue to deploy. So think of it as I can see it, but it's not going to stop anything. And then on a failure, it will actually just initiate a rollback and then roll back the stack. So using the CloudFormation CLI, you can write your hooks using Java and Python. And then for Python, we created a package that allows you to do guard rules inside that Python package, makes that hook process creation easier, so you can focus on the guard rules and get that hook up and running quicker. So we're going to look at an example of that right now. So this is a file layout of a hook using CloudFormation Guard. We use the rules folder to include all of our guard rule files. You can include multiple files in here. And then for this package, it's also gingified the templates. So you could do some parameter substitution. So think of things like I might have different AMIDs in different regions, or KMS keys that I want to have specified depending on what region or account or environment that I'm in, right? You can kind of substitute those in by kind of putting the templates in there gingified. This hook is available publicly on the registry, so you can enable this in your AWS accounts today. It's just to look for it in the AWS community S3 bucket versioning enabled hook. There are a bunch of other hooks out there that you can go and look at. I just wanted to call that this one is out there publicly as well. So in the example here, what you kind of see from the CloudFormation stack events page, right? This is an example of creating an S3 bucket that didn't have that versioning enabled. Obviously, we get that failure. We can see what the hook was that failed. And while I didn't show it, if you actually just kind of highlight that area, it'll give you a more detailed message of what that failure was. So think of that guard output you saw earlier, kind of in that hover screen. So I do want to spend a few slides talking about post-deployment now. So we're going to start with this DynamoDB table that specifies the read-write capacity, tag values, and key schema. So during the life cycle of this resource, it may be that during an incident, somebody manually flips the read capacity or adds a new index to increase the speed of a query. While we like to drive those changes through code, there can be scenarios to resolve an issue quickly that these changes are made outside of code. So this will result in that resource, from a CloudFormation perspective, that expected state to drift. So with CloudFormation drift detection, we can evaluate a resource to see if it's drifted from its expected values. Drift detection will not remediate this resource, as we may be undoing a change that is required to keep your application up and running. So in this scenario, it may affect your customers if I were to flip the read capacity back down or to delete an index, right? But this visibility allows me to now decide how I want this to be resolved. Do I want to flip it back to the right values that CloudFormation state has expected? Do I want to go through a process of re-importing that resource with the expected state that I want it to be in and doing an import process? Again, it's kind of leaving you up to that flexibility of how to do it, but it allows me at least to see that difference. So in summary, our goal is to shift feedback about IAC left, right? We want to enable the developers to have that information about misconfigurations before they've even done a commit or they've done a PR, right? And we want to give that to them as soon as they can, as soon as we can. So, and then additionally, right, if there are scenarios, right, where changes may happen outside of there, we can use services like AWS config to still evaluate the resource for compliance. So, and then using solutions like CloudFormation Guard, we can get this common DSL to define rules in every stage of the lifecycle. So Guard is supported inside AWS config as well. And so you can still kind of use that same DSL logic to write your rules at all areas. So now that we've discussed those tools, I'm going to turn it over to Damien to discuss how GoDaddy has built governance into their infrastructure as code.
Kevin? Sorry. Awesome. There we go. Okay, so Kevin and Eric have done a great job of telling you about the infrastructure as code tools that are available. And what I want to do is I want to talk to you about what we actually built at GoDaddy using these tools. So my name is Damien Silbergleith, and I'm a principal engineer at GoDaddy, and I lead the cloud governance team. Cool. So I'm going to talk to you about our story of building our next generation cloud governance system, which we call Stack Safeguard. And it's built on top of CloudFormation hooks and CDK. Together, these tools allow us to increase developer productivity and velocity while also maintaining cloud security and compliance and setting us up to adopt the latest and greatest tools coming from our AWS partners. But before we begin, I got to talk to you a little bit about GoDaddy. You may have heard of us. We're the world's largest domain registrar. We've been around for over 25 years. And we have millions of customers spread out all over the globe. Our mission is to empower everyday entrepreneurs to live their best lives and be the best that they can be. And we do so with a suite of tools that carry them from the idea to developing a website, adding e-commerce, taking mobile and physical payments, and then building their brand and legacy. So how do we do that? Well, at GoDaddy, we have thousands of developers distributed over hundreds of development teams. These teams focus on a diverse suite of products that are as varied as our customers are. Our choice to partner with AWS to do this was obvious. As the leading cloud provider, we knew that they had the speed and the scale to reach our customers where they're at. In the early days of our partnership, we were really worried about two major issues, right? We call it the $1 million weekend and staying out of the news. And so I'm pleased to say that in the 6 years that we've been working with AWS, we've managed to accomplish those goals, not end up in the news, and stay away from those and keep those costs under control. So how do we do that? Well, we knew that no matter what, we had to empower our developers to move quickly. But if you want them to move quickly, you also have to have a really good governance system in place. You got to mitigate that risk of that quick movement. And so that solution that we developed, we knew that it would need to be controlled by a small team of cloud architects who could define both the capabilities of the system as well as the guardrails that would need to be there. We knew that all deployments needed to match our security and compliance guidelines, and we needed as light a touch as possible so that those developers could move quickly. And so that led us to our first governance solution, which was built on top of AWS's Service Catalog. Now, if you're not familiar with Service Catalog, I'm not going to do a super deep dive, but I will tell you a little bit about it. So the idea is Service Catalog lets you take your CloudFormation templates and package them up as products. And once you have those products, you can build a catalog of the products and distribute them out to the accounts in your organization. At GoDaddy, we used this service to build a walled garden. So developers were not allowed to deploy infrastructure that was not first defined and implemented through Service Catalog. We actually removed their ability to be able to do those kinds of deployments. And then we encouraged the teams to make contributions into the Service Catalog through an internal open source development model. Using Service Catalog in this way has been a really big success for us at GoDaddy. Like I said, 6 years, stayed out of the news. That's really a great win. And we've been able to leverage the knowledge of that central team of cloud architects, as well as a distributed group of engineers to build a robust catalog of products that our development teams can then adopt and get working with. Once a problem is solved and a product is added to the catalog, that solution is in place and can be used by all these other development teams, and it really accelerates their productivity. But not always perfect. Service Catalog is an excellent service, but our implementation of it, the way that we chose to use it at GoDaddy, has made some challenges for us. The first one that we really run into a lot is what I think of as AWS the GoDaddy way. And so what that means is because the developers have to launch products out of our Service Catalog offering, an experienced cloud developer who joins GoDaddy and really just wants to build the way that they've always built using CloudFormation or whatever it is they want to use, they're kind of limited in what they can do because they first have to go contribute to the catalog to make that happen. And for new developers who are just learning their way into the cloud, they can't really go out onto the internet and use trainings and find documentation in order to drive their learning experience. Further, team agility can be hindered because making novel changes to their infrastructure requires updates to the products in our catalog. So not every change has to go that way, but when it does, it means going through the whole developer cycle. So they have to make the contribution, we have to review the work that they've done, accept it into the catalog, merge it, deploy it, and then eventually it lands in their accounts. There are also some problems that we've had with scale here because there's a linear relationship between the speed of the deployment of the catalog and the number of accounts that we have. In the beginning at GoDaddy, that wasn't a big deal. We only had hundreds of accounts, but now we have thousands. And so this can take a significant amount of time to roll the catalog out, especially when we've made large updates to the catalog. In worst case scenarios, we've seen it take days to get through a deployment. So we knew we needed to address some of these things, right? I mean, these days, developer productivity is really one of the biggest focuses that we have. And so given all of that, we thought, what could we do to really make a better system? And so we began piecing together requirements for our Governance 2.0 solution. It seems kind of obvious, it almost goes without saying, but first off, it's got to be safe, secure, and reliable, right? If you don't have that in a governance solution, what do you really have? And to do that, we really wanted to drive transparency. So one of the big pieces of this was, could our developers deeply understand what governance looked like? Could they read the actual rules that we wrote? Could they understand them? And so carrying on, one of our first principles was to unlock the potential of all of that wonderful wealth of information that's out there on the internet, right? If you're a developer and you want to read examples or you want to check out the amazing documentation that exists for services like CloudFormation, we want you to be able to use that. We wanted you to literally be able to go out there and copy and paste an example from the internet and deploy that into your GoDaddy Trusted Landing Zone account. It all just needed to work right out of the box. So again, this idea of developer velocity, developer productivity, and moving fast, these are fundamental goals for the system. And we knew what we wanted to do. And we turned to our partners at AWS to talk about how we might go about implementing that. And what we came up with, I think, is a pretty novel solution. Yeah, so let's dive in and take a look at what that actually looks like. So here's a beautiful diagram. It's a simplified diagram of our Stack Safeguard solution. That's our Governance 2.0 solution. And so we're going to begin with this developer that you see on the left. And you can imagine that developer wants to do a deployment of cloud infrastructure. And so the first thing they need to do is assume this very special role. It's the Stack Safeguard deploy role. The role is special because what we've done is given it the permission to create any infrastructure that it wants to create, so long as it does so first via CloudFormation. And this is really key. Because in that account, we've also installed one of these CloudFormation hooks that they were talking about earlier. That hook will examine every deployment that happens and in turn call a custom Lambda function that we've written. That Lambda function then reaches out to a centralized S3 bucket, which has our rules in it. The rules are versioned by release, and the Lambda knows which version to grab. It pulls those in, and then compares those rules to each resource in the template, ensuring that these resources are compliant with the rules that are there. If any of those rules are in violation, the deployment is blocked and we fail the deployment. And then we output a message to the user at the console showing them the resource that was in violation, the rule that was violated, and most importantly, links back to our documentation that let them examine what a successful deployment would look like, even the actual code that builds the rule. And so we really wanted to drive that transparency and get them to understand all of that stuff. This gives them an opportunity to then iterate on their deployment and redeploy. Assuming everything goes fine, the output from the deployment is just a native CloudFormation stack. There's nothing special going on here. It's just a stack, and the resources in it are just native CloudFormation resources. The beauty of this is that it's totally transparent, and if you didn't know the hook was there, you really wouldn't know the hook was there. So Stack Safeguard has been a resounding success at GoDaddy so far. Developers who are using the system report greater happiness as well as greater productivity. They're able to get up and running quickly and use normal CloudFormation to get their job done. The learning curve for deploying cloud infrastructure has now gone to a sunk cost. Whereas once you really had to understand what we were doing, now for the most part, it's not any more difficult to deploy with the hook or without the hook in place. We managed to isolate the rules into single files, governing one and only one thing, and keeping and only governing the things that we must govern. So best practices are not part of our rule system. This keeps the rules clear, simple, readable, and most importantly, maintainable over the long term. One of the biggest benefits, though, is that we've unlocked tool independence. In our prior system, we had some restrictions about what tools you could use, but now, as long as you're deploying CloudFormation, it doesn't really matter the tool. We strongly recommend the use of CDK, and you'll see why coming up. But if a team decides that CDK doesn't fit their need, they're welcome to choose whatever they want to use. Now, not everything is perfect. So there are some things we're still working on in the system. So the first one is that this is a deploy time only governance. So we're really only getting a chance to inspect the infrastructure at the time that a deployment happens. This means that over time, if teams are enabled to change the infrastructure, we don't know that the infrastructure stays compliant. And we're looking to other AWS managed services to address this, specifically AWS config. There's some really exciting stuff happening in that space right now. At the same time, in our service catalog solution, developers really had the luxury of being ignorant about what was going on inside a given service catalog product. They didn't really have to know the details. They could just deploy it and assume that governance was good and they were good. But in our modern system, teams have to know a little bit more about what they're doing. We've given them a lot of power, but with that power comes responsibility. And so they're going to need to go read some of these rules. They're going to need to understand what's going on there, and they might even have to go through a couple of deployments, banging their heads up against the guardrails that we have. But we knew this was going to be a problem, and so right out of the gate, we set about seeing what we could do to reduce this friction. And that led us to developing a CDK library. And what we did is we built this idea of GD Stack. So GD Stack is a drop-in replacement for the CDK stack construct, which if you're not familiar with, the stack construct is just where you build all of your stuff in CDK. That's just your starting building block. So what we did is we just inherited off of it, because CDK is full object-oriented language, which is really fantastic. And then we added new features, two killer features, actually. So the first is what we call the Trusted Landing Zone info, or the TLZ info. This is account and region-specific contextual information about the GoDaddy account that they're doing deployments into. The beauty of this is then that information becomes available to them as dot properties of the stack that they're working on. So this is all IntelliSense driven, right? The editor is going to help you do code completion. Really, really helpful stuff. The other killer feature that we built was something we call something that we call conformers, and that's built on top of CDK aspects. Now, aspects are this cool part of CDK where what you do is you get this component that implements a visitor pattern. And it lets you go and touch every resource in the stack that's being built. And so we saw that and we thought, wow, this could be really cool. Maybe what we could do is get in there ahead of time and fix some of these problems that the developers are going to have when they do deployments. So if there are rules that are going to block their deployments, and those rules have one and only one outcome, one possible answer, maybe we can solve that for them and make it easier. So enough talking about it. Let's look at some code and just some light code, nothing too crazy. But we'll dive in, and let's just first look at GD Stack, right? So this is a simplified view of GD Stack. And what you can see right at that top line is what I said, right? There's GD Stack extends stack. So we're just inheriting off of it, and we're adding some new features to it. Line 35 and line 36 right underneath. That's the definition of the GD-SSG conformers and the trusted landing zone information. So that's how we get these to be available as dot properties of the this object that you would then be working with. Further, we can see the constructor implementation here, and if you look line 137 to 139, at the bottom right there, that's the registration of the conformers in the stack as aspects. Now, why is this important? Well, this is all built in for you, right? So if you're a developer at GoDaddy and you inherit from GD Stack instead of from CDK Stack, you get the power of these conformers, you get the opportunity to use the trusted landing zone information, and it's all right there. This is sort of our way of taking a page out of Amazon's playbook of doing undifferentiated heavy lift. This is something we knew developers could do on their own, but if we could do it for them, we could really accelerate that productivity story. So moving on, I want to show you an example of how we actually can use the trusted landing zone information inline in a CDK application. So here you have a Lambda function. This is just a basic declaration of a Lambda function. This would go on your stack, and it would give you a Lambda. You can see all it's really doing is console logging out the meaning of life. And here, if you look line 17 and line 20, you can actually see the use of the trusted landing zone information. So this Lambda, we're binding it into a VPC. And instead of asking the developers to go look up what the name of their VPC is or what the IDs of their subnets are, we just make that readily available right on the stack, and they can access it, again, using code completion and the like. So it's very straightforward, very easy to use. And finally, the last bit of code I want to show you is a conformer. So I said conformers were implemented using aspects. And aspects, they will visit every resource in the stack. And because of that, the first thing that we need to do, if you take a look at line 40, is narrow the scope of what this conformer is going to impact. This is similar to the way that we wrote our rules, where the rules are focused on one and only one thing. Our conformers take a similar approach, right? We want to keep it simple that way. So you can see on line 40, AWS S3 bucket. This is a conformer that's only going to impact a bucket. If we look from line 43 to line 50, we see a block of code that defines the actual conformance that's going to happen here. Now, this is looking at a very specific feature of our ecosystem. GoDaddy requires that all S3 buckets write their logs to a very specific bucket within the account. And we do that so that we can ship those logs off to our security partners, and they can take care of doing whatever the magic is that they do with those logs. But we need to make sure that these deployments go out that way. So we have a rule in Stack Safeguard that will block any deployment that doesn't do this logging configuration. But we wanted to make this easy for the developers. And so what we do right here, take a look at line 45, we just say add a property override for logging configuration. We're just going to override that. And then line 47, you can see the destination bucket name is this account info access log bucket name. Now, I know it's a this, it's not saying the trusted landing zone, that's implementation details, doesn't matter. This is coming out of that trusted landing zone information. It's available to you right there on that stack. So that's where we're at with Stack Safeguard today. Again, we launched over the summer, and it's just been a really great success. We're getting great feedback from the developers who have managed to onboard it onto the system, and all our new accounts are using this. This is the way that we're driving our developers to write new infrastructure at GoDaddy. We do have some more bases that we want to cover. So GD Stack is really cool, and that project is really great, but we want to take that to the next level. We want to expand that out into a full-featured construct ecosystem where, much like in our service catalog offering, we have these off-the-shelf, ready-to-go expressions of infrastructure where teams don't necessarily need to know all the nitty-gritty details. They can just take one of these constructs out of this library and go and deliver it into the account that they have. Central to that goal is a developer community that's able to make those internal open source contributions. So we're really looking to do that and continue the best parts of our service catalog solution while leaving behind some of the ones that didn't work so great. Further, we know we need to expand the rule set that we have. We got to write some more rules. Our system does not enable services if there aren't rules for them. So when we set out, we looked at the 80% case. What are the services that most teams are using, and could we get those implemented out of the gate? We did, and again, it's been great, but we were running into those edge cases where teams are asking for services that we didn't implement, and we're saying to them, great, you're a subject matter expert on this. Partner with us, make a contribution into the rule set, and help us build out the tools that you need to be successful. And then the third part, which again, I mentioned config before, but it's really something I'm excited about. So we really want to get this idea of reactive controls in place. So we have these proactive controls where we can block a deployment when it's happening, but if we could let teams modify their infrastructure and still ensure that that infrastructure stayed conformant, it'd really be powerful for us as we go forward. There are some great offerings coming from config on this, and one of the things that we know is that adopting CloudFormation Guard would be a big win for us to get to this space that we want to be in. So overall, our partnership with AWS has really just been fantastic. And I personally was lucky to join GoDaddy right as we began our public cloud migration. And I've been really lucky to be right at the center of the Cloud Center of Excellence during the time that I've been at GoDaddy. I've had the chance to work on cutting-edge solutions with AWS and even contribute to discussions about how we want to see products developed. And it's been just amazing to see this sort of feedback loop play out, where we go to them and we're like, hey, it would be cool if it did this. And then, a few months go by and you start seeing that happen. Specifically with hooks, it's just been awesome to go from ideation with them and to see the process of getting to a beta and then getting that out. And now to be able to build a production-ready governance system using these hooks is just absolutely fantastic. And I'm super lucky to be at GoDaddy. It's a great company with really strong engineering values, and we're always willing to build cutting-edge solutions on top of the latest and greatest offerings that AWS has for us. I know I said it a lot. I feel really grateful, and I do. And I want to say thank you to all of you for coming to the talk. I want to say thank you to giving me the opportunity to be up here to talk about what we've been doing. We've got a survey that we'd like you to fill out. It's in the mobile app. Please get in there and just give us some marks, give us some feedback. We'd love to hear your thoughts. And we're going to wrap the session here, but we will be hanging around. Eric, Kevin, and I will hang around. We'd love to take questions or comments or thoughts. We'd love to hear your feedback. So thank you all so much.